Those two we still haven't talked about yet. So if you can take out your homework 7 and 8, we'll start with questions from 7. If anybody has any, I'd be happy to address them. Okay, how are you?
I'm okay, I'm alive.
That's a low bar to clear, but I'm glad you did it.
Yeah.
Will people ever go back online like early?
I don't know.
Election's over.
I don't have any more information than you do.
I did one, so
Guys, leave politics out of it, they're so bad. Let me talk about that, please.
Again, I'm looking for questions from homework 7, if anybody has any. Ben?
I can't even log into my tablet.
15. Okay. So on 15, we're asked to solve using the quadratic formula. So first thing I notice is that this is not quadratic because it has an x cubed in it, right? But that's not a factor of x. So I can do that. Okay there?
Yeah.
Now if I apply the zero product property, I get x equals 0, and then x squared plus x minus 3 equal to 0. And I'm going to use the quadratic formula to solve this part of it. So the values for a and b are 1, and the value for c is negative 3. So I know x is equal to negative b plus or minus b squared times a times c all over 2 times a. So 1 squared is 1. Minus 4 times 1 times negative 3 is positive 12. So 1 plus 12 is 13. And I can't do anything more to simplify the square root of 13 because that's prime. So there is my final answer. You're welcome. Hallie? Sure. Stefan, did you have a question about this one or something different?
I thought it said b equals negative 1/3.
Oh, okay. No problem. I just wanted to check to see if it was a question about that problem or something else before I moved on. So, Allie, you want to do number 9. So the directions here say solve using the reverse order of operations. So the first thing I'm going to do is I'm going to add that 4 to both sides. And then I'm going to divide both sides by 9. And then to get rid of the squared, we'll square root both sides. Now when we do that, we have to remember a couple of things. So when we square root both sides, we know that it creates a plus or minus. And when we square root a fraction, we can think about the square root of the numerator and the square root of the denominator. And that's helpful because the square root of 4 is just 2, and the square root of 9 is just 3. So then all I'm left to do is subtract 3 from both sides. So I have x is equal to negative 3 plus or minus 2/3. But this I can combine, right? There's no reason I can't combine 2/3 and negative 3. But because of the plus or minus, I have separate problems. So I have to do negative 3 plus 2/3 and negative 3 minus 2/3. To add these fractions, I need to make a common denominator. That common denominator would be 3. So when I multiply negative 3 over 1 by 3 over 3, it creates negative 9 over 3. And negative 9 over 3 plus 2/3 is negative 7/3. So there's one answer. And similarly, negative 9 over 3 minus 2/3 is negative 11/3. And there's my other answer. Is that okay, Hallie? Okay. Evan? Okay. subtracting 13 from both sides. And then divide both sides by -2. And a negative divided by a negative is just a positive. And I'm going to leave that as a fraction. Then we'll square root both sides to get. So when we square root both sides of an equation, that creates a plus or minus. And when it's a fraction, I can take the square root of the top and the square root of the bottom. So next I would want to just add that 6 over. And I can't combine a 6 with something with a square root on it, so I have to write it separately. And now if you remember from your geometry class, we didn't like to write fractions with having square roots in the denominator. So we need to take care of that here. So to do that, we'll just multiply the top and bottom of that fraction by the square root of 2. So square root 13 times square root 2 is just square root 26. And square root 2 divided by, or square root 2 times the square root of 2 is square root of 4. So you could write it that way, or if you wanted to, you could make a common denominator and write it all as one fraction. You could write it this way. Either or is fine with me. They are equivalent representations, and one is no more correct than the other. Is that okay with you, Evan? Sure, no problem. I can wait a second.
When you multiply by the square root of 2 over the square root of 2, where does that come from?
So you remember in geometry, you don't like to have a fraction with a square root in the denominator. I chose to multiply the top and bottom by the square root of 2 over the square root of 2 so that it got rid of the square root that was in the denominator. So that's the only reason I'm doing that step, is just to make it look better. You know how, like, if you get an answer of 2/4, we don't really leave our answers 2/4, so we call that 1/2. Now, there's no real reason we need to call it 1/2. It's not like any more correct to do that. It's just the convention. So the same thing is true here with the square roots in the denominator, is the convention is we're going to not leave our final answer that way. And the way you do it is get rid of the square root in the denominator, just multiply the top and bottom of the fraction by whatever that square root is in the denominator.
So then when it's square root of 26 over the square root of 4, why multiply it back to 2?
Well, the square root of 2 is different than the number 2.
Oh, it's not square root.
Yeah, there's no square root. Square root of 4 is just 2. Okay. Good questions. Again, like making sure you understand what's going on and why we're doing stuff is super important, right? The why did we do that questions are good questions to ask. Who else on homework 7? Okay, are we ready to talk about homework 8? Questions from homework 8? Alexis? Certainly. Okay. So the formula here for 9, if the absolute complex number is just the square root of a squared plus b squared. So in this, it's the square root of, which is 25 plus 144. And 25 plus 144 is 169. And the square root of 169 is 13. And that's it. Is that okay, Alexis? Evan?
So, the subtraction mark in the opening problem not mean anything?
Well, I mean, if you really wanted to think about this as like 12 squared, it's still going to be positive 144, so it doesn't really matter. I mean, yes, it does, but like, no, it doesn't. You know what I mean? But yeah, fair question for sure. In this problem, you would not be penalized at all by just forgetting about the negatives, since you're squaring everything anyway. So, Stefan.
Oh, what's the I mean again?
I is equal to the square root of -1. We define that as the imaginary number, and it was what we used to build the set of complex numbers so we could answer questions where we end up having to take the square root of a negative. Is that okay? Okay. Others from homework 8. Happy to do more. Evan? 8. Okay. So to divide two complex numbers, which is what this problem is asking us to do, what we need to do is get the i's out of the denominator of the fraction. And the way we do that is we're going to, when I have a full complex number at the bottom that has both a real and imaginary part like this one does, is I'm going to multiply the top and bottom of this fraction by its conjugate. So the conjugate is the same thing, but just with the different sign in the middle. So instead of 3 minus 2i, I'm going to just multiply the top and bottom by 3 plus 2i. And then I'm just going to FOIL these out. So 4 times 3 is 12. 4 times 2i is 8i. 7i times 3 is 21i. And then 7i times 2i is 14i squared. And in the denominator, I have 9, 3 times 3, and then 3 times 2i is 6i. Negative 2i times 3 is negative 6i. And negative 2i times positive 2i is negative 4i squared. So I can combine my like terms. Negative 6i and positive 6i cancel out. 8i and 21i become 29i. And remember that since I is equal to the square root of 1, I squared is equal to negative 1. So this part becomes like negative 14, and that part becomes like positive 4. So if I combine that, I have positive 12 and negative 14, so that's negative 2 plus 29i. And then I have 9 plus 4 is 13. Negative 2 over 13 plus 29 over 13i. That's kind of the worst one.
I got lost.
Okay, where did I lose you at, Evan?
After you wrote down after you FOILed and got all the.
So the first thing I did was I combined my i's. So like 8i and 21i is 29i. And then positive 6i, negative 6i just cancel out. They give 0. Okay there. Positive 6i and negative 6i, that gives you 0. And then I have to take care of the I squareds. So I squared is equal to negative 1. So this becomes 14i squared becomes just negative 14. And negative 4i squared becomes positive 4. So then I just took the 12 and added the negative 14 to it to get the negative 2. And the 4. 12 minus 14.
Oh, yeah.
Okay, Stefan?
So going back to the page, this problem.
Okay.
Alright, so how did you get 3 plus 2i over 3 plus 2i from?
So I'm always going to multiply the top and bottom by the conjugate of the denominator. So the conjugate is the same thing with the different sign in the middle. So if I had 7 minus 6i, I would multiply the top and bottom by 7 plus 6i. Whatever the conjugate is of the denominator is what I'm doing.
Yeah, I didn't see the whole page, so I thought it was just you had a new set of fractions.
Ah. Okay.
So it becomes -2.
Yep. Separate fractions, right, where they both have the denominator 13. Okay. Others from homework 8. Ben?
Can we do 13, please?
Sure. So here it says, use the reverse order of operations to solve this. So we'll start by subtracting 22 from both sides. And then to get rid of this 1/2, we'll multiply both sides by 2. Then we'll square root both sides to get rid of the squared. Now, because we square rooted both sides of this equation, we have to be aware of a couple of things. The first is because we square rooted both sides of an equation, we create a plus or minus. Because we're square rooting a negative, that's going to create an I. Okay, there.
So anytime you square root a negative, it becomes an I.
Yep. Right, because I is equal to the square root or is the square root of -1. So like -40 is okay with that? You don't have to show all that work, but that's what's going on behind the scenes. Okay? And just subtract the 8 over. And the 8 can't be combined with an I or a square root, so that definitely has to just be written separately. And then the last thing that we could do is we could simplify the square root of 40 a little bit. So 40 is the same thing as 4 times 10. So the square root of 40 could be the square root of 4 times the square root of 10. Okay, there. And the square root of 4 is just 2. So I can just make that 2i square root 10.
But if you put 4i square root 10, it would be right.
That would be incorrect.
The final answer is -8 plus minus 4i square root 10.
Right, that is incorrect. Because it's square, which is 2.
Oh, okay.
Right.
So if it was square root 4i square root 10?
Well, there's no point in breaking up the square root unless you can take the square root apart of it, right? Like that's the point of breaking that square root up, is so that you can get rid of some of the stuff that's under the square root. If you can't do that, then you just leave it. Like if we go back to this one, where was it? It was over on the previous homework.
Thank you. It was
Right here, where we had the square root of 26. That's 2 times 13, right? But we didn't bother with that because you can't take the square root of 2 or 13. So like, there's no sense in breaking it up.
I keep forgetting that 2 doesn't have a square root over it.
Yes, yes. So just be a little bit careful with that, but that's the idea.
Why did you multiply by 2?
I multiplied both sides by 2 to get rid of the 1/2.
Oh, okay, so if there's a fraction in front of
You can multiply by the reciprocal, right? That's all I did there. It's the same thing as dividing by 1/2, but like dividing by a fraction is kind of a weird concept. Just multiplying by the reciprocal, multiplying by 2 is way easier than dividing by 1/2. At least to do in your head or whatever. Alexis. Here's the thing. I wouldn't mark that wrong, but if you're taking a standardized test, that's not the answer that would be there. So I think it's important that I present like the answer that you would encounter like if you were taking an ACT. So like you can at least go, okay, I got the square root of 40. That doesn't match anything here. But maybe it's the same thing as something here. You know, let me see if I can simplify that a little bit further. I wouldn't mark it wrong on a test if you left it as a square root of 40. But a lot of you are going to take a test like that this year. So I think it's important that we kind of keep that that I go and I show that stuff whenever I can. You know what I mean? But yeah, I want to be clear as to how I would grade something like that. And typically for a class like that, if you give me this, these two things, if you converted them to decimals, are the same exact decimals, I wouldn't mark it wrong, unless the point of the problem was like simplify this radical, where like I want you to rewrite it instead of the square root of 40 as something else. But on a problem like this where there's so much else going on, I wouldn't mark you down. But it's an important skill that you have. You know what I mean? So you should try to do that. You know what I mean? Okay. Last calls on homework 8 here. Okay. So today we have just a little bit of new stuff. Yes, Stefan, of course. So last time we had met, we had just finished combining this idea of reverse order of operations and completing the square to create this quadratic formula. And then we had noticed that, hey, some of these problems are still a problem because we have to square root these negatives in some of these problems. So we extended our definition of the real numbers to create the complex numbers. So now we could solve any quadratic, even if it involved taking the square root of a negative. We had finished doing that. And we had created this pretty nice quadratic formula. So what I want to do today is just take a few minutes and talk about some other things we can use the quadratic formula to do, other than just solving. So again, if you didn't remember, when we say we're talking about this. So for ax squared plus bx plus c equal to 0, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And specifically, the part that we're going to be talking about today is this piece right here that's called the discriminant. And the discriminant can tell us a couple of things other than just acting as part of our formula. So one thing we can use the discriminant to do is determine the type and number of solutions to a quadratic equation. So if that discriminant is positive, you're going to get 2 real solutions. If that discriminant is 0, you're going to get 1 real solution. And really, when we say 1 real solution, we really mean 1 unique real solution. Really, you're getting 2 solutions, but they're both the same answer. So remember back in some of these factoring problems that we had worked on, occasionally you get things like x plus 2 times x plus 2. Now, if you were solving that quadratic, you'd set each of those x plus 2's equal to 0, and you get the solution x equals -2 twice, right? It's the same solution. You're getting it 2 times. That's what we mean here when I say one real solution. You're really getting 2 solutions, but they're the same solution, both of them. So we're going to call that just one answer for this purposes. Is everybody okay with that idea? And the third situation is if the discriminant is negative. And here's where we get 2 imaginary solutions. So let's say we have x squared plus 2x plus 5. Well, I can identify that the a is 1, the b is 2, and the c is 5. So if I wanted to calculate the discriminant, that's 2 squared times 1 times 5. That means we're getting 2 imaginary solutions. Okay with how we kind of can use that discriminant, Joseph?
Can you zoom out a little bit?
Mm-hmm.
Thank you.
Sure. Right, all we're doing is just a little piece of the quadratic formula that can tell us some information based on whether it's positive, negative, or 0. Evan?
So you multiply -4, 1 and 5, wouldn't it be -4 minus 20?
So 2 squared is 4. And then 4 times 1 times 5 is 20. So I have 4 minus 20.
Oh, okay.
Is that okay? Okay.
I thought what you did was you put -4. I thought you multiplied that by 1, and then you did the -4 times 5.
Okay. Is everybody okay, though, on how I can use this little calculation to make that determination? It's pretty easy, right? You just plug the values into the formula and then interpret it. The other thing that the discriminant can tell us that's even better than that factorable. Now, we've run into situations where the quadratic wasn't factorable, right? And usually we had to do this by exhaustion. We had to check all the possibilities to make sure nothing worked. And sometimes there were a lot of possibilities to have to check, right? Well, here we can do a quick calculation and figure it out right away. Fair? So perfect square numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, etc. What's significant about those numbers? Well, it's like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. They're things that are, when you take the square root of, you get a whole number. Okay with that? Yeah, sure. So for example, if we have x squared plus 5x plus 2, well, we can check this is factorable or not. Now, it's easy to see in this case that this is not factorable, right? But we've run into situations where this was not easy to tell just by glancing at it. But here we have a nice quick calculation that can tell us right away that this is not factorable. Now, for the most part, in practical concerns, I just kind of start by looking at the thing and seeing if I can factor it, because the not factorable situation doesn't come up that often. But before I say something's not factorable, after I've thought about it for a minute, I would certainly do this check so that I know, okay, it really isn't factorable, or, ooh, I must have missed one of those stupid factors. Let me go back and look at it again. I guess this thing is doable. You know what I mean? Joseph?
What is DS?
That's a P
Oh, okay.
for perfect square.
Yeah.
Sorry, that's just my bad penmanship. Okay with how to use this? Again, pretty helpful, especially when some of these factoring problems, if the numbers get big, sometimes it's a lot of things to have to check to make sure it's not factorable. If you get the notion that it's not factorable, will tell you right away definitively, okay, yep, not factorable, or like, oh, nope, you just haven't found it yet, keep looking, which is nice, right? Okay. That's it from this piece. So what I'd like for you guys to do now is, if you have your graphing calculator with you, I'd like you to take that out. I don't know why I closed that. Because what we're going to do now is program our graphing calculator to solve the quadratic formula for us. So we're going to run through a PowerPoint kind of detailing how to do this.
I'm stuck in the menu. I don't know how to get out.
So just press second and then the mode button, which is right next to it. Yep.
Oh, okay.
So that'll exit you back to the main screen. That'll work regardless of whatever menu you're in. Joey, to answer your question, this PowerPoint is on the Resources tab on our PowerSchool page. We're also recording this lesson, so there'll be a video of kind of me going through the PowerPoint also. Yeah, of course. Okay. All right. So if you have your graphing calculator with you, or if it's in your locker and you want to go get it so you can follow along, you're welcome to do that. In fact, encouraged to do that. In fact, if you don't do it now, you should do it at home on your own, because this is a very useful tool that you'll want to have programmed onto the graphing calculator that you'll use to take your tests with and stuff. So this is quite helpful. All right, so go ahead and turn your graphing calculator on if you haven't done so already. And we're going to begin by pressing the Program button, which is located right there on your graphing calculator. When you do that, your screen should look like this. What I need you guys to do now is I need you to tab over so that you're on the New tab and select Create New. So move over so that you're on the New tab up there at the top, like my screen shows. And where it says Create New, press Enter. Now your screen should look like this, and it should be asking for a name. You can name your quadratic program whatever you want. I'm going to name mine Quad, but you could name yours Rufus or Juliet or, Solvinator or whatever you'd like.
Where are the letters? Yeah, I don't know.
So if you look above the buttons on your calculator, often there's a little green letter above that button. So I think on this name, everything is already alpha locked. So if you press the button with the letter on it, it'll put the letter there. You should call it the catulator because you like cats.
I'm gonna do admin.
Okay, that's good.
Yeah. Wait, where's A? Oh, I think I messed something up. I knew you were gonna do that.
I like baseball. At least
I pressed like the A button and it just like did something weird.
So did you press this A button or did you press that A button?
I pressed.
So
Okay.
so the A is above this button, so you need to press like that button.
Okay.
But let's do this.
I don't think it was locked. Thank
Yeah.
you.
So we'll re-alpha lock it because I think you turned the alpha lock off. But now you just press the button, so you don't have to do anything else.
Mr. Cooling,
Yes, sir.
can you say how you did that first step again?
So I pressed the program button. I moved over to the new tab, pressed enter on create new, and then typed in a name.
Okay, I hit second on. I didn't realize it.
Actually, I don't want to delete her. How do I delete the letter?
You just press the delete key that's right next to the mode.
Oh my god. I want it to be happy.
Okay. So just a quick brief description of what how this program's going to work. So what you're going to need to do is we're going to have the calculator ask us to give it the values for A, B, and C that will plug into the quadratic formula. So the calculator will take those values, store them as a variable, and then use those variables to calculate the quadratic formula. It'll output the results of those calculations into a new pair of variables that will have the calculator display on the screen when it's done. So that's kind of the program in a nutshell. So the first thing we need to do is have the calculator ask us for the values for A, B, and C. So to do that, before we do that though, we're going to do something just formatting wise to clear the screen so it looks nice when it does this outputting. So what we're going to do now, after you've typed in your name, press enter, and you should be at a screen that looks like this where it has the program name at top and then just like a blank colon after that. Okay there? Now press the program button again, and you're going to be at a menu that looks like this. Everybody okay there? Press the right arrow key to move over to the I/O menu. And then from the I/O menu, we're going to pick the clear home command. Yep, so you'll press enter on the clear home command. That'll put clear home now on your screen, just like mine. And you'll want to press enter again to move to the next line now. So you should have your cursor should be below the clear home, not right next to it. Anybody still working on doing that? Okay. Next up, we're going to press the program button, go over to the I/O menu, and pick the prompt command, and then press alpha and the letter A. You press the program button, move over to the I/O menu, select the prompt command, and then type the letter A. You press the program button, you press the right arrow key to get to the I/O menu, you select the prompt command, which is the second option, and then by pressing enter, that's what you mean by select it, and then you'll type the letter A by pressing alpha, and then the letter A.
I think I messed it up. Mine says get.
Yeah.
Mine does too.
What do you mean get?
Like T-E-T, parentheses.
Well, you didn't pick prompt.
Yeah, but then after I just highlighted prompt and then we did the alpha and then the A. Are we supposed to click prompt first? Let me see. I think so.
Yes, you select prompt from the
I
menu.
thought we just highlighted it.
Highlighting doesn't do anything.
No. It's okay. Got it.
It's like trying to tell your parents how to program their television or something. It's like, no, now you have to press enter to pick the thing. It's like, no, you double click the icon. No, you don't have to double click a link. This is what I deal with when I have to try to tell my parents how to do something. It's like, oh my God. You know? All right. Have we got it? Okay, you're going to repeat that process 2 more times to put in prompt B and C.
Oh my god. This is a lot.
So you press program, over to the I.O., find prompt. That's because you didn't press enter to make a new line.
Oh. Well, I didn't mean it. Wait, do I just press delete?
Sure, you can just delete the prompt command. That will work.
Okay, wait, I did it.
I'm so proud of you.
I did it. Now mine just doesn't have an A.
Well, you might have to go back and retype the A.
You were laughing at me. Oh, I'm good.
Oh my gosh, I'm popping up. I did it.
I named my program after
That's good.
Yeah.
Okay. Make sure that you're on a new line. So your cursor should be below prompt C. Everybody's okay? What we're going to do now is we're going to type in the quadratic formula. Now the quadratic formula has a plus and a plus or minus in there, right? You can't do a plus or minus on your calculator, so we're going to have to do 2 versions of the formula separately. So the first version is going to have the plus sign here.
I have to put all that myself.
Yep.
Oh, God. I don't know how to do that.
So the parentheses are on above the 8 and the 9. In front of the first B, this is a negative sign. Oops. That's the negative sign. That is a subtraction symbol, though.
Okay, class.
So B is alpha, and then the apps button
Yeah, I got
to
that.
get
And
B.
then where's the square root?
Press second, and then the x squared button.
Okay. So then it gives me another. Oh, yeah, that's fine.
But you're supposed to have that other parenthesis, so that's good.
Then another B. How do I square?
Wait, Joe, where are you finding
Well, if you press the x squared button, it puts the squared symbol on there for you. Make sure you get both sets of parentheses after the C. There are 2 sets of parentheses after that C. Make sure you get both of them. Yep, so the slash is the division. So how do you get the arrow?
Arrow.
See the arrow?
I'm still looking to see. Wait, so you just type in the parentheses.
How'd you make that arrow?
How do you make the arrow? You're going to use the STO button, which is located right there above the on button.
Oh, I got that.
That is press it. How do you already get the arrow?
I'm done.
Okay. Once you've finished, press enter to move to the next line. And you're going to do it again, except this time you have a minus sign instead of a plus sign and an E instead of a D.
How long have you been teaching for?
I don't know, like 10 years.
Actually, not that long.
No, more than 10 years, like 12 years or 13 years.
Have they all been here?
No.
What? Here, can you show us the meeting where?
Okay, what's up with the next thing? The second problem? The exact same thing.
No.
Oh, wait, I messed up the first one. It's supposed to be.
Can we do it on this one?
No.
Oh, you can?
That is non-programmable.
That's kind of lame.
Dang it.
You're coming. Oh, I'm down.
Wait, oh my god. Wait, can you
Haley.
do the arrow part again?
Yeah.
If this all deletes something,
You just
we're
go to
gonna
the thing
try.
above.
So the STO button right above the on button,
Get out of
I
there.
got it, I'm done. Mine.
I'm mad.
I'm feeling anything.
the good news is we only have to do this the one time, and then we have a program that we can just call and it'll run over and over and over again, which is awesome. This is the beauty of the computer, right? Is that it's basically a machine that can mimic any other machine.
What if I messed up then?
Well, we'll do some tests at the end to make sure everything is working correctly, and we'll find out real quick. If it's not, we can debug it then.
Mine is like messed.
Okay.
Wait,
Irrigate.
What do you mean? How long have you been doing this whole time?
it's, actually, I'm still on the phone.
Oh my, crying up there.
Ben, be quiet.
Have you done your flight prompts yet?
Yeah.
We actually
I
have,
actually,
we actually have everyone in our rollback for like the first time since the first day.
I know.
wait, no, I just deleted.
It did no, it did not.
Hit clear.
Press the program button.
Yeah, press the clear button, no longer back.
Alexis, press the program button where it says go to the edit tab. Do you see the edit tab? Okay, press second and mode. Alexis, press second mode. Now press the program button. Go to the edit tab. See your name, program name, and press enter. And it should be right where you left off.
No, like, I think,
It's all there.
no, it's not. No, it's not.
You watch the Mandalorian?
No, I deleted like the last.
Well, that's as much as you're going to get.
They come
I
out
know,
every
I think I
Friday.
actually deleted.
Well, if you need to retype something,
Yeah, I know, I
okay, go ahead and retype it. All right, next. Make sure you're on a new line. Make sure you're on a new line. And then we're going to press the program button. Go over to the I/O tab and select the output command. That is command 6 from the I/O menu. And you're going to type in output 6, 1, D. And then output 7, 1, E. The comma is right above the number 7. Right above the 7.
The camera on here?
No.
Do we get
Not to my knowledge.
Don't worry, Mr. Click.
I don't even know what just happened, but
Basically, like, when I type in like a this, and it's just.
So your alpha lock is on.
I think I got it.
So if you just press second and alpha. Alpha again. There. See how the cursor doesn't have an A on it? So now you can use the symbols. If you need to get to the B, you'll press alpha and get the B. And then just kind of keep going.
I do not know how I deleted it.
You probably just fat fingered something.
I stopped. I didn't do it.
Even Fox knows you Yeah. Is this the no? I want the 265.
Okay. And our final step. Make sure you're on a new line. And you're going to press the program button and go down to near almost the very bottom and pick the stop command.
Up control.
Control.
I don't see a stop.
It's Command F. It's almost all the way at the bottom.
I got it. Wait, that's it?
And once you've got the stop on there, like my screen has here to the right, you can press second in mode and exit out.
Stop.
It's supposed to be gone.
Oh, okay. You're so annoying. I was like, stop. No, stop. Stop. Okay.
Hold on.
Guys, you guys are annoying.
Wait, so now we're done, right?
So let's test this.
I don't know. I don't have like the output thing. I haven't figured it yet. That's a bummer.
So press program,
Why do I find that program?
go to the I/O menu, and then look for the word output. Press enter to select that. Type in how it looks. The comma is above the number 7.
Wait, 6-1.
Yep.
No, I did taste that way. I just spoke yesterday.
It's annoying.
No. Bro, I'm so angry today. Is the day I left my calculator at home because this is gonna be so hard. Dude, Jonathan was like that for 3 years ago.
Stop. What do I do for this?
Press the program button, and then from the CTL menu, it's almost all the way at the bottom.
This is on the resources tab.
This PowerPoint is in the Resources tab on PowerSchool if you need to do it again yourself.
In the worst case scenario, I can ask them for help once they do that.
That's true. And this video will be on PowerSchool as well. So, okay. So, now that we're done with that, let's do a test to check to see if our program is working. Okay? So to run your program, you're going to press the program button from the EXEC tab. You should see your program name. Select it and press enter. On your home screen, it should say program whatever the name is. Press enter again. And then you should see something that says prompt A. Or A equals question mark, excuse me. So this is the problem that we're going to check this with. So what should we type in for A? 6. Good. So type 6 and press enter.
Wait, so once we're in the program clock,
Yeah. Press enter to select it, and then press enter again to run it. What's B gonna be? 1. What's C gonna be?
35.
Negative 35.
Got the answer. Negative 2.5.
You're Jewish?
Negative 2.5.
So you should have gotten 2 outputs.
Oh my gosh!
where are you looking?
That's a failure. X minus 3. 35.
So those should be the 2 outputs you get. Riley, we got one more thing to do, if you can hold it for a minute. All right. Shh. Did anyone have issues getting those 2 outputs? Okay. We need to check one more thing. You don't all you need to do is press program again, select your program and press enter again. You don't have to clear your screen. You can if you want to, but you don't need to. And we're going to do the same thing for this one. So the A is,
Mine said error.
the B is, and probably almost all of you get an error here, right?
Yeah.
What does your error say?
What, non-real?
Non-real answer. What do you suppose that means?
Imaginary.
It has an I in it.
Hey, non-real answer.
Two imaginary.
So your calculator can handle this. It's just not set up to do it right now. So let's change our option so they can deal with these answers with I's in it.
Mr. Kulik, how do you just like know this off the top of your head?
12 years.
He built this.
12 years, Ben. All right. So go ahead and press quit. Go ahead and select quit. And now press the mode button on your calculator. On your screen, about halfway down, you should see highlighted the word real.
Oh, there's one that says that.
Do you see that?
Yeah.
Right next to that, it should say A plus BI. Move your cursor so that it's on A plus BI and then press enter. Once you've done that and A plus BI is highlighted, you can exit out of this menu by pressing second in mode.
Do I click enter?
Yes, that's how you get it to highlight.
Spider-Man just click clear.
No.
What?
Spider-Man just click clear.
Sure.
Hey, 2 plus I.
And now if you rerun your program on this problem, you should get 2 plus I and 2 minus I.
Hold on. Got it.
Oh. 2
Yeah.
plus I, 2 minus I.
Yep, you should get 2 separate answers.
Correct.
How much are they?
How much are we?
It's correct or it's incorrect?
Everybody okay with their program now working?
Yes.
Good.
I'm looking at one right now.
Let's practice with it then. So here's a time solving practice. All these problems you can do using the quadratic program we just created. If you don't have your calculator with you or you weren't able to write the program today, take this home, time yourself with it. Once you get a chance to get the program to your calculator.
Mine's a good enough calculator.
Joey, where this one?
Dude, it's Can we still try without a calculator?
You can, but it's gonna be rough.
You're not gonna.
I don't even know how to do it. I'll leave it at home. I don't have a calculator. It's the beginning of the year. They're like, bubblegum, One, two, three. There's something me. What is this? How did you ever know that?
Alexis, why did you have it on your computer?
I'm never reporting.
Alexis, if I just
You should have seen that. You should have seen how inappropriate.
Okay, proof it. Oh, actually they did.
Who's there? Can you prove it? Can you prove it?
You.
Okay.
What did I see?
So, those of you at home, we're looking at timed solving practice 1. You should see that in the content library. If you finished your quadratic program, you can work on this now with us. If you haven't finished that yet, you can always do it later on your own. No big deal. We're going to take 5 minutes to work on this. On your marks, get set, go!
My calculator doesn't work. I gotta do it.
Exactly. No big deal. Can we turn off the sound on our video?
Sorry.
Thank you, Ben.
Sorry, boys.
While they take the thing, how is your family? How's life?
I'm just trying to stay healthy, man.
I feel that, yeah. That functions better.
Yeah?
You take cold showers, your body functions better.
Well, I usually after my workout in the morning, the shower's not terribly hot because,
Yeah, you work out in the morning, that's plus too, right?
yeah. Well, it's when you have an hour commute home and you have a wife and a child, and
You live in Iowa. Where do you live?
I live in Grosse Pointe.
My cousins live in Grosse Pointe.
Amazing.
I
You
live
live all the way in Grosse
I live an hour
I
away.
used to live in Grosse Pointe.
Why are you teaching
I was like
here
19
if you
minutes
live all the
away.
way in Grosse Pointe?
Wait, where's that at?
It's the passion fruit, it's far.
It's on like Lake St. Clair, just north of Detroit.
Or do you live in like,
I live in Woods.
okay, they live in Western
Do you go like to Lake St. Clair over the like when you're like with family?
Um,
No.
I mean, like, we don't have a boat.
Like you're like, you live high, right?
We live, it's like, our house is like a mile away.
Really?
Yeah.
I always got my arm cut off at Lake St. Clair.
That's cute.
That's terrifying.
That water's kind of cold, and it's not like a shark again. Not really, but it's really big.
This C won't go away.
Oh, dude, I fell off.
That's because you have to put a number in.
I fell off.
But I just need to go away.
Well, you can't do that.
Why was it?
You just have to rerun the program.
Why didn't you have the safety?
So if you're missing one, you have to put a 0, right?
I don't know,
When I
it's
get
not
the
very
image, do I
hard.
get them right?
No, like
It's
50 on
it's
3 doors.
unrelated.
Oh, it's bigger than everything here. Yeah, like 50 on it. Better than everything. If anybody gets this going, I'm just actually, yeah. What was that?
Do you have a different job before becoming a teacher?
Yes, I was a chemist.
Really?
Did you say he was a Marine?
No, Kevin, that's so cool.
Yeah, that's what I did before I was a teacher.
That actually is really cool.
Why aren't you a chemist anymore?
I finished Mr. Kulik, are you proud?
This is a math teacher.
Well, there's a lot of reasons, but one of them comes down to, like, to do anything interesting, I would have needed, like, probably to get a doctorate,
Oh, that's a lot.
which is, well, for a chemistry degree, it means, like, you can't work and get a doctorate because you really are going to be spending 40 hours a week in the lab doing, like, lab work. So it was either, like, go and invest a bunch of stuff or a bunch more time and effort in a job that I wasn't super happy with anyways, or try to do something else, and I chose something else.
Do you like teaching?
Most days.
My mom hates it.
That's honest.
That's pretty cool. You were a
She's been teaching for like 30 years.
Yeah.
I want to be a teacher. Just like pretend to be an alcoholic.
Thank you.
And I'm like a fake bottle of like water. Oh, like I'll be like, oh jeez. Like they're think, but I'm not.
All right. So let's check here.
Riley has to go to my area.
Yes, go ahead. You're welcome.
I'll tell you everything.
Since you're serving.
So here are the solutions.
Oh, I did it right.
Oh, you have to write down the first part that they give you? What is that?
There's 2 answers for each of these.
Wait, if you, like, on a test, like, if you don't write down, like, the whole decimal, like,
It will, Alexis, it'll depend on the directions, on what I'm asking for. Okay? But what we mostly wanted to do on this was to figure out if our quadratic formula, our program is working correctly and get you some practice using it. That's basically was the point of this. If it's working, then you're good.